Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Enol content in keto-enol tautomerism depends on the stability of the enol form relative to the keto form. The enol form is stabilized by 1. Intramolecular hydrogen bonding in the enol form, forming a 6-membered Chelate ring. 2. Extended conjugation of the C is equal to C double bond with adjacent carbonyl or aromatic groups. And 3. The acidity of the alpha hydrogen, more acidic alpha-H leads to more enol. Moving on to the next step. A. 1. 3. Dibenzolmethane. Dibenzolmethane C6H5 co-CH2 co-C6H5 a 1. 3. Dietone with 2 phenyl groups. B. Acetylestone. 2. 4. Pentanedione CH3 co-CH2 co-CH3 a simple 1. 3. Dietone. C. 2-pentanone CH3 co-CH2 CH2 CH3 a simple monoketone with no activating group on the other side. D. Ethyl acetoacetate CH3 co-CH2 co-2H5 a beta ketoester. Moving on to the next step. Options. C is a simple monoketone. There is no second carbonyl to stabilize the enol through chelation or extra conjugation, so enol content is negligible, tilde a very small percent. Option. B. Acetylestone is a well-known one. 3. Dietone with tilde 80% enol content in neat liquid due to intramolecular H bonding forming a 6-membered ring and conjugation of the enol C is equal to C with the adjacent C is equal to O. Option. D. Ethyl acetoacetate is a beta ketoester with tilde 8% enol content. The ester group is less electron withdrawing than a ketone, so the enol is less stabilized than in acetylestone. Option A. Dibenzolmethane. The enol form is C6H5C or is equal to CH co-C6H5. In the enol form, the C is equal to C double bond is conjugated with both phenyl rings and the remaining C is equal to O group, giving extensive delocalization. Additionally, intramolecular hydrogen bonding still forms a 6-membered Chelate ring. The 2 phenyl groups provide additional resonance stabilization of the enol form beyond what 2 methyl groups can provide. This results in dibenzolmethane existing predominantly, greater than 95%, in the enol form in solution. And for the final step, both are 1, 3 dietones capable of enol chelation, but in A, each carbonyl is flanked by a phenyl group. The enol tautomer of A benefits from conjugation extending into both phenyl rings, cross-conjugated aromatic stabilization, making the enol significantly more stable than in acetylestone. B. Experimentally, dibenzolmethane has higher enol content, tilde 100% in nonpolar solvents, compared to acetylestone, tilde 80%. C. Has negligible enol content due to lack of a second electron withdrawing group. D. Has lower enol content than B, because an ester is a weaker activating group than a ketone. B. Has high enol content but less than A, because methyl groups do not provide additional conjugative stabilization to the enol. Therefore, the correct answer is A. Therefore, the correct answer is option A.